Good evening everyone. Today's lecture is about the law related with black body radiations, that is Stefan's law. So first we will see the statement of this law, then we will derive this law with the help of Planck's radiation law. So let us first see the statement, what this law states. According to this law, the amount of energy radiations emitted from a perfectly black body per unit area per second is proportional to the fourth power of its absolute temperature. This means what? The temperature at which the black body is and the energy radiation emitted at that temperature is directly related with its temperature. Greater the temperature, greater the energy emitted from a perfectly black body. And this is related as the fourth power of that temperature, and removing this proportionality sign we have a proportionality constant sigma, and where sigma is nothing but Stefan's constant. Now we will see the derivation of this law. So according to Planck's radiation law, we have E nu d nu. Nu is the frequency of radiation emitted, is equals to 8 pi h nu cube over c cube. Now total energy density E is getting by integrating this value. So E, we left with E is equals to 8 pi h by c cube into integration from 0 to infinity nu cube divided by e raised to the power h nu by kt minus 1 d nu. So let us, for the sake of simplicity, consider h nu by kt is equals to x. So where nu is kt by h into x simply, and d nu will be kt by h into dx. So from this equation 3, substituting the value of d nu in terms of dx, we have 8 pi h by c cube integration from 0 to infinity. This is the value of nu, frequency, nu cube. So nu cube into x cube divided by e raised to the power x minus 1 into kt by h into dx. This is the value of d nu. So we left with this equation. Taking the constant terms outside from the sign of integration, we have 8 pi k ki power 4 t ki power 4 divided by c cube h cube into sign of integration x cube e raised to the power x minus 1 whole power minus 1 into dx. Now taking e raised to the power x out common from this equation, so this term becomes 1, and this factor divided by e raised to the power x becomes e raised to the power minus x. And hence, so as total energy radiated by a body is always positive, so therefore x, the factor x, has to be more than 1. So we have E is equals to 8 pi k ki power 4 t ki power 4 into 0 to infinity x cube e raised to the power minus x. Solving on opening this term, we have 1 plus e raised to the power minus x plus e raised to the power minus 2x plus into dx. Next, e raised to the power minus x is taken inside, and we left with this equation. So now using the standard integral, which states 0 to infinity x ki power 3 into e raised to the power minus mx into dx is equals to 6 by m raised to the power 3 plus 1, that is 4. So we have E is equals to 8 pi k raised to the power 4 t raised to the power 4 divided by c cube h cube into 6 by m raised to the power 4. Here m is equals to 1, here m2, here m3. So we have this type of solution. So now solving this further, we have this value, standard value. Substituting this value, we left with E is equals to, this is a constant term, into temperature raised to the power 4. So we derived this law, we reached at this law with the help of Planck's radiation law. So this is nothing but the energy emitted by a black body is directly proportional to the temperature, absolute temperature, and this is directly related with the fourth power of temperature. So this is nothing but Stefan's law. So, and this value is in standard value, and this is given as. So this is the derivation for Stefan's law. Next we will discuss about Bose-Einstein.